All right. So binomial theorem, we're going to be looking at Pascal's triangle. So first, I want you to go ahead and multiply that out. Just like you've always done before. While y'all are finishing that out, I'm going to start it. Just look up when you're done. So depending on how you approached multiplying those together, you should have ended up with that same solution. Now, x plus y to the fourth, yes, is annoying to multiply that out 4 times, but it's doable. Pascal's triangle is actually going to help us make this a whole lot simpler on ourselves. Like I said, if it's on a test and you want to multiply it out 4 times, go for it. But again, Pascal's triangle will make this a whole lot easier on us. It's a shortcut. And I would hope that if it got somewhere higher than to the 4th power, where you're having to multiply things out maybe to the 7th, even sometimes to the 5th power, it's like, whoa, this is too much. Okay. So Pascal's triangle, it's actually on the next slide, but I am going to start it. Did you need that still? You did. Okay. William, did you need that still? I kind of just switched that slide there. I'm going to start the pattern and hopefully see if you can catch on. All right. So you're always going to start off with a little triangle of 1s. Okay. You're always going to start the next line and end the next line with a 1 to see if you can catch on to the pattern. Who knows my next number? You what? 5. What's my next one? The next one? 10 again, and see who's catching on. What's my next number? And then what? 15? 15? What's my next number? 15. Does anyone see it yet? What do you see?
It's adding the 2 right above it. So it's like 1 plus 5 equals 6, 5 plus 10 equals 15, 5 plus 7 equals 20.
I thought it was 4, 8, 16, 32. Maybe I could run a different number.
So watch here. Let's start from the beginning. Well, let's do green. It'll look like a Christmas tree. 1 and 1. It's me 2. 1 plus 2. It's me 3. That's how I get 4 here, and then 6 here, and then 4 here. I keep going. This adds to get 5. I get 10 here, 10 here, and 5 here. So then if this is 6, this is 15, this is 20. What's my next one? 15. The next one. And then we end with a 1. This can keep going on forever and ever and ever and ever. Do it.
If you add all the whole row up, like, what goes to 2? It goes from 2, then from 4, from 8, 16, 32, 64.
Huh. Interesting. Never looked at it by adding them up. All right, so this is Pascal's triangle. Look at this row in comparison to the answer we just got on the last problem. How does that correlate? It's the coefficients. Our answer from the last problem was a 1, and then a 4, and then a 6, and then a 4, and then a 1. Okay? So Pascal's triangle is going to tell us our coefficients, and then from there we're going to set up the exact same thing each time. Once you catch on to that pattern, then these are pretty quick and easy. Okay? So Let's take the last problem we just did and do it again, but using Pascal's triangle. All right. I'm going to move the Pascal's triangle onto the whiteboard so y'all can still see it as a reference. Oh, I ran out of space here. All right. So let's do this same problem, but using Pascal's triangle, okay? So this is our lucky number right here, 4, okay? 4 is everything we're going to be using. I'm going to say what do our exponents add up to, and you'll say 4. We'll go to what line does 4 appear? It's that 1, 4, 6, 4, 1, okay? 4 is our number, all right? So, like I said, we are going to do the same exact problem, but using Pascal's triangle, okay? So Pascal's triangle, when you see 4 appear first, okay? That got to be a little bit confusing earlier because if I say where it appears first in general and we're looking to the 6th power, people might choose this line, okay? But where it appears first. They actually call this row 0, this 1, this 2, this 3, this 4. But if you notice, that's what's showing up first. That's what I mean when I say it's showing up first. Okay, so we're going to use those coefficients. What I would do is I would give yourself a little bit of space in between. Okay, you're going to give each one of those coefficients an x and a y. Okay, so if this was 3x plus or minus 2y, then you would give everything a 3x and a minus 2y. Okay, and we've got tons of examples today. Okay, we'll have to, I guess, finish it another time too, but you usually start it. That's the first portion right there. That's the non-calculator. You're welcome. All right, so give everyone an X and a Y, and I want you to get in the habit of using parentheses because when we get to actual numbers or we get to negatives and stuff like that, then that's going to be a big deal when it comes to exponents. This is the first time y'all seen this, so don't freak out after the first example. We've got plenty of others that we're going to do. Okay, what's my magic number I was talking about? 4. Okay. So I start with my x's, and I'm going to go 4, 3, 2, 1, 0. I'm going to do the same thing for my y's, but backwards. 0, 1, 2, 3, 4. So some people go 4, 3, 2, 1, 0 that way, and then they come back 4, 3, 2, 1, 0 that way. Some people memorize it in that particular way. But if you notice, every single one of these exponents add up to 4. So that's 4, that's 4, 4, 4, and 4. Okay? Now all we have left to do is simplify and reduce this. Okay? So anything to the 0 power is just 1, so those go away. And let's write out our answer. So 1 times x to the 4th is just x to the 4th. Then we have 4x cubed y. Then we have 6x squared y squared. Then we have 4xy cubed. And then we have y to the 4th. Which is exactly what we got. This is fine how this is. Because there's not necessarily a standard form when you've got 2 variables going. So once you catch on to this pattern, like at the beginning, you might be like, oh my gosh, that's a lot to know. Once you catch on to this and catch on to the pattern, this one line or 2 lines, basically, of work is a whole lot better than that nonsense, especially if it gets higher than to the 4th power. Okay, if you get higher than that, it's again going to be a lot more than just multiplying 2 things together and 2 things together. Okay, let's do another one together. What we just did. Okay, let's look at that first one together. All right, so graded. I know that back in the day we could just multiply these out together. Okay, we're not going to do that. I'm going to show you Pascal's triangle with this. All right, so I am raised to the 2nd power. So I'm looking at this row right here. So 1, 2, 1. Excuse me. So now I'm going to put in parentheses 2x and a negative y. That's when you bring the sign with it. If it's positive, don't worry about it. But the negatives we need. Okay. So my lucky number is 2. So I start with 2, 1, 0, 0, 1, 2. All I have left to do is simplify. So my 0 powers cross out. And I get 2x squared, which 2x squared is 4x squared, times my 1, just gets me 4x squared. Then I have 2 times 2 times negative 1. So I get negative 4xy. And then a negative y squared is a positive y squared.
Wait, why is the first one 4x squared?
Because you have 2x squared, so that's 2x times 2x. So that's why you have to put parentheses around them. Does that make sense?
Why is it minus 4x?
Because I have a minus here. And that's raised to the first power.
It all goes together.
So it's 2 times 2 times negative 1 technically. Any other questions on how I'm getting numbers and stuff like that? Okay, try the next one on your own. See how far you can get. Any of y'all have Carter's at the AGU?
Yeah.
Have Carter's number?
Yeah.
They just have to say you get a question mark. Sure he's not passed out.
He actually texted me. He
Oh.
said he's not having a good time.
Okay, at least he's okay. Or gotcha.
I hate to.
All right, so we're gonna use this row right here with the 1, 3, 3, 1. So I have a 1, a 3, a 3, and a 1. I knew that I wasn't gonna have this space here. Let's do this. There we go. So I have an X and a negative 3Y. lucky number here is 3. So I start with 3, 2, 1, 0, 0, 1, 2, 3. Cancel out my 0 terms. And I simplify the rest. So this just gets me x cubed. So I get negative 3 to the first power, which is just negative 3, times 3 gets me a negative 9 x squared y. Then I have negative 3 squared, which is a positive 9, times this 3 gets me a 27 xy squared. And then lastly, I have negative 3 to the third power, which gets me negative 27, and then y cubed. Okay? So deal with the exponents first, and then multiply it to the coefficient that's incorrect. If you need to show a second step, go for it. If you need to show what these actually equal, and then multiplying to the coefficients, go for it, okay? It's up to you if you need that extra piece there. Any questions on that one? Okay, let's try some more. Go ahead and try both of these. And yes, we'll get some pretty big numbers here. I don't need to use the calculator or anything.
want us to do the other one too?
Do what?
Want us to do the other one?
Yeah, you're doing both. can set up the first one while y'all are finishing the last one. I'm just gonna go into that other one and I'll write the other one on another sheet of paper, another slide. I don't know what I meant. Right out of space. All right, so yes, we end up with some pretty large numbers here. We have 6, 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5, 6. So I get rid of my 0 terms. And here comes the party. All right, so we get 1 times x to the 6th, so that's just x to the 6th. I get negative 5 to the 1st power times 6 gets me a negative 30 x to the 5th. I get negative 5 squared times the 15 that's in front, so 375 x to the 4th. I get negative 5 to the 3rd power, so negative 125 times 20. Then I get negative 5 to the 4th power times 15. Get negative 5 to the 5th power times 6. And I get negative 5 to the 6th power, which gives me my last term. Who got it?
I got it.
I like it. Okay. Doing the exponents first hopefully will be helpful, and then multiply it to the coefficient so it's not as crazy going on there. Okay. All right, so let me do the next one right below it. All right, so this is to the 5th power. So 1, 5, 10, 10, 5, 1. We got 2 and negative y. Wait, where'd my 1 go?
Will you want us to memorize anything above 6? On Pascal's chart?
I mean, technically you don't have to memorize anything because you can keep building this on forever. I don't think I get 2. I don't think I ever go above 10. But I can't remember. Hopefully I'm not too mean, right?
Can I look up bonus question once I collect the 20?
Like a massive one. I should.
Don't do that.
I have a feeling though on this
No,
test / quiz whatever that y'all are gonna be like, nah, I think I did really well on this, so I'm gonna skip that part.
if I was to select the 20, I'd probably.
Yeah. Or I'd make it a multiple choice question and y'all would just circle C and move on. Okay. Number here is 5. Scroll up so I can see what's going on here. So 2 to the 5th gets me 32. And then I have 2 to the 4th times 5 gets me 80. But be careful, there's a negative right here. And it's raised to the first power, so this is going to be negative 80y. Then I have 2 cubed, which is 8, times a positive 10. This negative's inside with the square, so it doesn't. You've noticed, guys, if we have a negative, it alternates. I don't know if y'all noticed that or not. But we have a plus sign here, so plus 80y squared. Sorry. So then now I have 2 squared, which is 4, times 10, which is 40. And then I do have this negative from the cubed here. So minus 40y cubed. This negative goes away because it's to the 4th power. So 5 times 2 gives me a positive 10y to the 4th. And lastly, I do have my negative y to the 5th. Okay. So, huge that you show this part right here, okay, in blue. All right. If you accidentally multiply or you forget something or whatnot, there'll be less credit taken off than if you didn't show me any kind of work. Okay. All right. Any questions on Pascal's triangle? And it's true, if you did have extra time left, nothing is stopping you from multiplying these out 6 times and 5 times. Okay. If you really had extra time and you wanted to double check that you got it right, then that's totally fine. Okay. Kind of like with all the sequences and series stuff. You might be somebody that follows the formulas, but then you might want to go back in and double check by literally just continuing to add over and over and over again, or multiply over and over and over again. Okay. All right. Any questions? All right, let's get started on that homework.